Hi everybody. Today we're going to talk about percent yield and percent error. Percent error and percent yield are just two different ways to talk about how close or how far away from the actual results you should have gotten. And unfortunately, neither of these equations are given on the AP exam, but they do ask you questions from time to time about the percent error and the percent yield of the results of an experiment. Okay, so percent error is something you've probably seen in my own class, but percent error is just a way of taking the actual result, so what you should have gotten, so the theoretical yield, minus what you got in the experiment. Now notice those absolute value bars there. Absolute value bars means it doesn't matter how you subtract them. It doesn't matter if you take experimental yield minus theoretical yield, because no matter what, you change your answer to a positive number. So whether it's 9 minus 7 or 7 minus 9, when you take the absolute value of those values, you end up with 2 no matter what. The important part with percent error is, yes, you have to subtract your two experimental values, but then on the bottom, you divide that by the theoretical yield. That's the most important part with percent error, is you divide it by the value that you should have gotten in the experiment, by the true value. Sometimes we call it the true value, the actual value, the correct value. Again, what the real value is for that experiment. Okay, and then obviously the experimental value is what you got in the experiment. Okay, now with percent yield, it's something similar to that, but notice that in this equation you don't subtract. Okay, you don't take the theoretical minus the experimental value. You just take what did I get in the experiment and what divided by what should I have gotten in this experiment. Okay, typically the percent yield is going to be less than 100%, and here's some reasons why, and I italicize this because of course they've asked questions about this. Why might your percent yield not be 100%? Why don't you sometimes get what you should have gotten? Okay, one reason is because sometimes the reactants aren't pure. Sometimes there's some impurities in those reactants. Sometimes some of the product is lost during purification. Some of it gets spilled, some of it gets heated up and turns into a gas, etc. Or you may have the reaction be reversible, so as you're forming some products, some of those products are reacting with themselves to reform some reactants, or they might be reacting to form what are called some byproducts, some products that aren't even part of that reaction. Okay, so just some ideas why you might not get a 100% yields when you do an actual reaction experiment. So here's a reaction. Aluminum reacts with oxygen gas to make aluminum oxide. In one such experiment, 23.4 grams of aluminum are allowed to burn in excess oxygen, producing 39.3 grams of aluminum oxide. So balance the equation. So right away we've got an even and an odd number of problem with oxygen, and with the oxygens we've got 2 and 3. So we need to put a 2 there, or excuse me, a 3 there and a 2 there, which means we need 4 aluminums there. Okay, so now it is balanced. What evidence is given to show that this is not a limiting reactant problem? Well, that right there certainly could give it away, saying you have excess oxygen. They only give you the amount of one reactant. That's another possibility. Okay, now let's get to the important part, percent error and percent yield. So the percent error is, again, what we're going to take the theoretical value minus the experimental value over the theoretical value. Okay, so how much aluminum should I have gotten? I actually did get 39.3. How much should I have gotten is I've got to do some stoichiometry to figure that out. 23.4 grams of aluminum. The molar mass of aluminum is 27 grams per mole of Al. And then from the balanced equation, 4 moles of aluminum are going to produce 2 moles of aluminum oxide. And then 1 mole of aluminum oxide has a mass of, let's see, aluminum's 27. There's 2 of them. That's 54. 54 plus 48 is 102 grams, if I did that correctly. Okay, and now I'm going to take 23.4. I'm going to divide by 27. I'm going to multiply by 2 and divide by 4. And then I'm going to multiply by 102. And that tells me that if I did this reaction 100% perfect, if everything went exactly as it should have, and there were, again, The reactants were pure. We didn't lose any of the product. And there was none of this aluminum oxide reversing itself or producing something else. We should have gotten 44.2 grams of Al2O3. Okay, and again, that is our theoretical yield. Okay, how much did we actually get? We actually got 39.3. So when I do percent error, I usually just look at the two numbers just so I don't have to think about absolute value. I just take the bigger of the two numbers, 44.2, and I subtract 39.3. When you do this, make sure you hit equals before you divide. Okay, because now we're going to divide by, again, the theoretical value. This is the most important part. Make sure you divide by the right number, 44.2, and then we're going to multiply by 100. So I'm going to take 44.2 and I'm going to subtract 39.3, and then on my calculator I'm going to hit equals. Because think about what your calculator does. If you just automatically hit divide, it's going to take 39.3 and divide 44.2 before it subtracts. Okay, your calculator follows the order of operations. So you need that top number to be completed. You need that 4.9 on the top. And now we divide by 44.2 and then multiply by 100 times 100 gives us a percent error of just over 11%, 11.1%. Okay, and actually, since this number only has two significant figures, technically our answer should only be 11%. Even though these both have 3, after you subtract, you only have 2, and then when you divide, you're using the division rule, so 11% is correct. Okay, for the percent yields, again, we take the experimental value, no subtracting on top. So our experimental value, again, was 39.3. So 39.3. And we're going to divide by the theoretical value. So experimental value on the top, the theoretical value on the bottom. We should have gotten 44.2. And again, multiply by 100 to get a percent. Divide by 44.2 times 100. And again, in this case, we have 88.9. Okay, one of the things that you'll notice, and you probably may already have, is that the percent error and the percent yield are kind of opposite of each other. Notice that if you add them together, if we had kept that one digit here, notice that when you add those two together, you should get 100%. So basically, they're kind of opposites of each other. Percent error is basically how wrong you are. And again, the lower the number, the better. Percent yield is how right you are. And again, you would like to get a 100% yield, but obviously sometimes you do not. Okay, but just to kind of help you remember the two of them, you want a percent error to be low, you want a percent yield to be high. And again, the two of them together add up to 100%.